In this video, we're going to look at rearranging equations or changing the subject of a formula. If you can solve equations, then you can rearrange equations. Let's go ahead and look at a very basic equation. If we were asked to solve 2x is equal to 4, all we would do is divide both sides of the equation by 2. That would give me that x is going to be equal to 4 divided by 2, which we can write as 2. That's nice and straightforward. I've simply used the inverse operation. If we go ahead and look at 3x minus 1 is equal to 8, we would start by adding 1 to both sides, so that gives me 3x is equal to 9. We would then divide both sides of the equation by 3. That would give me 9 over 3, which gives me 3. So all I've done is use now the inverse operations. I've added 1 and divided by 3. If we had now two lots of 5x plus 1 is equal to 4, I could at this stage expand the brackets, or I could simply divide both sides of the equation by 2. If I did that, I just have one lot of 5x plus 1 is going to be equal to 2, dividing both sides by 2. If I now subtract 1 from both sides, we can see that 5x is equal to 1, and dividing both sides of the equation by 5, we have x is equal to 1/5. So this time we've not got an integer or whole number value, so we just write it as 1 over 5 or 0.2. Let's say we had now 2x squared is equal to 72. The first thing I do is divide both sides by the 2. That will give me x squared is equal to 36. The inverse operation of squaring is square rooting, and we have a plus or minus answer. So x would be equal to plus or minus the square root of 36, which gives us x is equal to plus or minus 6. So all we're simply doing is undoing these equations using the inverse. The nice thing is these are all numbers. When we look at changing the subject of a formula or rearranging equations, we will have often letters instead of numbers, which is the thing that seems to confuse people. Let's have a look at another one. Let's say we got 3x minus 1 divided by x is equal to 5. I want to solve for x, so I want to get the x's on one side, the numbers on the other. So there's an x in the numerator and an x in the denominator. I'm going to multiply both sides of this equation by x to clear the fraction. That's going to give me 3x minus 1 is equal to 5x. I'm now going to subtract 3x from both sides, so we end up now with negative 1 is going to be equal to 2x, and I'm going to divide both sides of the equation by 2. That gives me negative 1/2 is equal to x, and we've gone ahead and solved that equation. We could go and check that that works by simply plugging in the values here. So if I put this in, we'd have now negative 3 over 2 minus 1, which is negative 5 over 2, divided by negative 1/2, which would give us positive 5. So that is looking at solving equations. If we now move on and look at a formula. So for example, we've seen in the past the area of a circle is given now as pi r squared. The circumference of a circle is given as 2 pi r or pi d. And if you've ever done any physics, you might have seen that the final velocity is equal to the initial velocity plus the acceleration multiplied by time. So this time we're looking at a formula rather than an equation. At the moment, A is the subject of this formula, C is the subject of this one, and V is the subject of this one. We can rearrange the formulae to make any other variable the subject of that formula. So for example, now this one here, the area is expressed in terms of the radius. Pi, remember, is just a number. So let's say I wanted to make r the subject of this equation. If we think about r was squared and then multiplied by pi. So all I'm going to do is work backwards from that. So the first thing I'm going to do to make r the subject of the equation is divide both sides of the equation by pi. That's going to give me that a over pi is equal to r squared. At this stage, I'm going to square root both sides, and that will give me plus or minus the square root of a over pi. That will now give me r. With this being a circle, we would say that it's the positive square root, as the radius can't be a negative number. So all I've done is undone it. If we look at this one's slightly easier. The circumference is 2 pi r. So what we did is took the radius and we multiplied it by this number of 2 pi. Therefore, if I want to make r the subject of the equation, I'm simply going to divide what I've just multiplied it by. So we can say that the circumference divided by 2 pi will be equal to the radius. This now gives me r as the subject of this formula. If we look at this one right here, we could make u the subject. So at the moment, v is the subject as it's expressed in terms of u, a and t. So if I look at this now and I wanted to make u the subject, well, we've got v and that's equal to u plus at. So u started its life off, it had at added to it, and that gave us v. So if we simply subtract this from both sides of the equation, that will give us u. So we can say that v minus at is going to be equal to u. U is now the subject of that equation. Let's say we wanted to make a the subject of the equation instead. Well, a started its life off, it was multiplied by t, that's what at means, and it had u added. So we need to work backwards. So this time I'm going to have v minus u is equal to a multiplied by t. I just want this to be a. Just imagine t was 2. All we would do to find a is divide both sides of the equation by the 2. Therefore, we're going to divide both sides of the equation by t, and a is now the subject of the formula. Of course, we could do exactly the same with t. We would just divide by a. So t started its life off, multiplied by a, it had u added, and that became v. So we can write that v minus u, as before, was equal to a multiplied by t. So if I want to make t the subject, it's going to be v minus u divided by a is going to give us now t, and t is the subject. Hopefully you can see this is fairly straightforward with just using inverse operations. In the video, we're going to work through some very basic examples and then look at some really quite challenging ones later on. So let's start off. We're asked to make x the subject of the formula, i.e. x is equal to something. So at the moment now, we've got 2x is equal to something. Y is the subject of this formula. So right here, if I want x is equal to something, well, x was multiplied by 2 to give y. Therefore, all I need to do in this particular case is simply divide both sides of the equation by 2. That's going to give me that x is equal to y divided by 2. So nice and straightforward. Just think if this was now 4, we've got 2x is equal to 4, x is equal to 4 over 2. It's just we can't simplify this one. A multiplied by x is equal to t, so we're going to divide both sides of the equation by a, and that will give us t divided by a. This one here, we've got 2f multiplied by x is equal to k, so we can say that x is going to be equal to k divided by 2f. 2f, now just think of this as a number. This number 2f was multiplied by x to give k, so x is going to be k divided by 2f. This one just here, we've got 4fr multiplied by x is equal to pk. So x will be equal to pk divided by this value of 4fr. And that has now made 1x the subject. X is the subject, not 2fx, not 4frx, not ax, it's just x. Okay, let's look at the next one. This one's nice and straightforward. X plus 4 is equal to y. So if we think x started its life off, it had 4 added, it became y. So we simply subtract now 4 from both sides. So it's y minus 4. X minus 7 was equal to h. So if we add 7 to both sides, x is going to be equal to h plus 7, or 7 plus h. This one here, and I'll just get myself some space. This time we've got now two steps. I'm going to add 3 to both sides. So we'd have 4x is going to be equal to t plus 3. I'm now going to divide both sides by the 4. So we have t plus 3 all divided by 4. Don't fall into a trap of just putting t over 4 plus 3. So nice and logical, nice and straightforward. Okay, let's do something slightly more interesting. Let's look at this one. We've got rtx, so rtx minus g is equal to k, and we want to make x the subject. So started off, x started its life off, multiplied now by rt, then it had g subtracted, which gave us k, so we're going to work the other way. So rtx will be equal to g plus k, or k plus g. I'm now going to make x the subject by dividing both sides of the equation now by rt. So rt. So that gives us now that k plus g divided by rt is equal to x. Right, let's have a look at this one right here. We've got now 3 lots of the quantity 2x minus 3 is equal to y, and we need to make x the subject. So let's just write this out. There is a temptation, as you might have done in the past, to expand the brackets. We're not going to do that. If we think about x was multiplied by 2, it had 3 subtracted, and then that quantity was multiplied by 3. So what we did, we multiplied by 2, we subtracted 3, and we multiplied by 3. What we're going to do is go the other way. We're going to divide by 3, we're going to add 3, and we're going to divide by 2. So if you want a little sort of map of what's happened, that's what we're going to do. So let's divide both sides of the equation by 3. That leaves me 2x minus 3 will be equal to y divided by 3. I now need to add the 3, so we have 2x will be equal to y divided by 3 plus the 3, and finally we divide both sides by 2. So we have x is equal to y over 3 plus 3 all divided by 2. With this you could tidy this up. In later examples we will tidy things up, but if you wanted to, we could now combine this fraction and we could say that x is equal to, if I just get a common denominator, the common denominator is going to be 3, so we would have y plus 9 all over 3 divided by 2, which we could now write as x is equal to y plus 9 divided by 6. So that is tidying the fraction up. If you like, you could say I'm multiplying all of this fraction by 3. That's another way of looking at it. But if you've got to this step right here, that's good going if you're new to the topic. Okay, let's have a look at this one right here. X divided by 2 is equal to a. So x was divided by 2, which gave us a, so we're simply going to multiply by 2. So that's going to give us that x is equal to 2a. If you want to draw this little map as you go, you're more than welcome to do so. It's entirely up to you. So let's look at this one. X divided by 2 minus 3 was equal to a. So if we write this out, so x divided by 2 minus 3 is equal to a. So x started its life out, it was divided by 2, it had 3 subtracted, and that became a. So we're going to work the other way. We're going to add 3, so x divided by 2 is going to be equal to a plus 3. We're then going to multiply both sides by the 2, and that will give us 2 lots of a plus 3, or 2a plus 6. Don't fall into the trap of just writing it's 2a plus 3. Okay, let's just do this one right here. So x plus b over c is equal to a. So let's write this here. X plus b over c is equal to a. So we want to get to the x. That's in the numerator. Consider x. X had b added. It was divided by c, and that gave a. So we're going to do the opposite. We're going to multiply by c and subtract b. So we have x plus b will be equal to ac, or ca. Generally speaking, we put these in alphabetical order, although it doesn't matter. So x is going to be equal to a multiplied by c minus b, and we would leave it like so. Any of these now? Let's do this one right here. So x over v plus b is equal to a. So x over v plus b is equal to a. And again, we're just making x the subject. So x started its life off, we divided by v and added b. So we're going to do the opposite. So x over v will be equal to a minus b. And then we simply need to multiply both sides by the v. So it'll be v multiplied by the quantity a minus b, and that would be our final answer. So there we go, just rearranging some basic formulae or equations. Let's have a look at some other ones. We'll grab some more up. Okay, so this time now, in the first one, we've got x squared minus 3 is equal to y. So if we write this out, so x squared minus 3 is equal to y. And again, we're making x the subject of the equation. At the moment, y is. So x started its life out, it was squared, it had 3 subtracted and it became y, so we'll do the opposite. We will add 3 to both sides, which gives me y plus 3. We now need to do the inverse of squaring, which is square rooting, so x will be equal to plus or minus the square root of y plus 3. It's important that we put plus or minus. So for example now, if I had x squared is equal to 25, then x could be equal to plus 5 or minus 5. We know that squaring a negative number will make it positive. Therefore, we're going to have a plus or minus answer if we're taking the square root of something. Okay, let's look at something else that's slightly more interesting. Okay, x squared plus y squared is equal to z squared. So x squared plus y squared is equal to z squared. A common error here is just to try and square root each of the terms. That is not correct. X started its life off, it was squared, and it had y squared added. We'll undo that. X squared is equal to z squared minus y squared. We just want x, so we'll now say that x is going to be equal to plus or minus the square root of z squared minus y squared. And again, make sure you're square rooting both of these terms, not just the square root of z squared minus the square root of y squared. That is not correct. Okay, let's look at this one right here. X squared over 3 is equal to y. So we have x squared over 3 is equal to y. So x started its life off, it was squared and divided by 3, that gave y. So we'll do the inverse. X squared is equal to 3y. We now square root both sides. X is equal to plus or minus the square root of 3y. And that is what we need. Okay, let's move on and look at some others. Which else? Right, we'll go for this one. Right, we have the root of x. So we have the root of x. In fact, we'll start with this one because it's a bit easier to see. So if we look at x here, x started its life off and it was square rooted. So what we want to do now is the inverse of that. So if I square both sides of this, we're going to get x back, and that will give me y squared. All I've done is squared each of these. If we think about the square of the square root, that's just going to give us x. And all we've done here is just squared both sides. What we do to one side, we must do to the other. Here, we're simply going to have y plus z all squared. So if we've got the root of x is equal to y plus z, we need to square both sides of the equation, and that will give me the quantity y plus z all squared. It's not going to be yz plus z squared. That is not correct. We square the whole one. Okay, let's have a look what else is. Okay, let's do this one. This time we've got now the root of x minus 2 is equal to y. So x started its life off, 2 subtracted, square rooted, that gave y, so we will do the inverse. Squaring both sides, x minus 2 is equal to y squared. We're now going to add the 2, x is equal to y squared plus 2. What else have we got? Let's do this one right here. So this one is just the square root of x, so the square root of x divided by p is equal to q. So x started its life off, it was square rooted, it was divided by p, which gave q, so we'll do the opposite, the inverse operations. So we're going to multiply first by p, So root x will be equal to p times by q, which we write as pq. Squaring both sides, x is going to be equal to the quantity pq squared. You could write this now as p squared q squared. Either or, these are the same thing. Okay, let's change. With this one, we would square both sides first because we have the root of all of this instead of just the root of x. Square both sides and then multiply. And I'll just do that one quickly. Let's just do that. So the root of x over p is equal to q. So x started its life off, divided by p and square rooted. So the first thing we'll do is square both sides. So that will give me x over p is equal to q squared. Multiplying both sides of the equation by p, we've got x will be equal to pq squared. Okay, let's have a look at this one right here. Now this one, we've got 3x plus ax is equal to 4. We want to make x the subject, and we can see that we've got x common to both of these terms. We factor this. So if I factor this now, x is common, and that will give me 3 plus a. So when you've looked at factoring an expression, we take now the common factors out. The common factor is x. That is going to leave me 4. At this stage, I can simply write now that if x multiplied by 3 plus a is equal to 4, dividing both sides by the quantity in the bracket, 3 plus a, then x is going to be equal to 4 divided by 3 plus a, or a plus 3. If we look at this one, common to both of these is x. That would have now x, we would have f squared minus 5 is equal to g. Dividing by the content of the bracket, we're going to have g over the quantity f squared minus 5. So we've gone ahead and made that the subject. Okay, let's have a look at some of these right here. Let's go for this one. So we got rtx. So rtx is equal to 7 minus mx. When we looked at solving linear equations, we got x's on one side and numbers on the other. So the first thing I want to do is get the x's, anything with an x in it, on the left-hand side, anything without an x on the right-hand side. So I'm going to have rtx plus mx. I'm simply adding this to both sides of the equation, which is going to give me 7. X is common to both of those terms. Factoring it, we're going to have rt plus m, which is going to be equal to 7. I'm going to divide both sides of the equation by the content of the bracket, which is rt plus m, or if you like, m plus rt. So we're just simply factoring. If we look at this one, we've got now uv squared x is equal to vx minus u squared. So what I'm going to do at this stage is simply subtract vx from both sides. That will allow me to have now the x's on one side and anything without an x on the other side. So just writing it out. Now, of course, what you could do is add the u squared to both sides and subtract the uv squared x from both sides. It doesn't matter, as long as we have the x's on one side and the numbers or the other values on the other. So minus vx, and that is going to be equal to negative u squared. Factoring the x, we can write x uv squared minus v will be equal to negative u squared. So at this stage we can divide both sides now, so we're going to have negative u squared over uv squared minus v. Now what you could have said is, well, we can take a v out here as well, and you could. Ultimately that's just a case of tidying this up, but we could have written at this stage, if we wanted, x v, because v is also common, u multiplied by v minus 1 is equal now to the negative u squared, and I could divide now by so we've got the negative u squared divided by v multiplied by uv minus 1. That is another alternative. Again, it's just tidying this up very slightly. So hopefully that makes sense and they're fairly logical. We're simply rearranging these using the inverse operations and a bit of factoring. Let's move on and look at some more. Okay, what have we got? Let's see if we can get some different ones. Okay, so with these ones, we're fairly comfortable with something like this. That would just be a case of solving the equation. Let's have a look at some more interesting ones. Let's start off now with this one just here. So what we've got then is x multiplied by y plus y squared is equal to 2y. We want to make x the subject. So what I'm going to do is get on the left hand side everything with an x in it, on the right hand side everything without an x on. So what we'll have is xy, which is x multiplied by y, plus y squared is equal now to 2y. At this stage, we could argue that we could divide both sides of this equation by y. I will leave that alone for a moment, and I'm just going to write now that xy is equal to 2y minus y squared. So if we just want x, what we could do is divide both sides of the equation by y. So 2y minus y squared divided by y. Really, we could tidy this up. If I wanted to at this stage, I could have factored it, and I could have written now that xy is equal to y, and then we would have had 2 minus y. Then dividing both sides of the equation by y, we could have had x is equal to the quantity 2 minus y, which we can write as x is equal to 2 minus y. So if you've got this, that's perfectly fine. It's just the final answer. We would write it like so. Okay, let's have a look at another one. Right, this one right here. 5 minus ax is equal to b. I'm going to look at this one a couple of different ways. So 5 minus a multiplied by x is equal to b. One way is to simply add the ax to both sides and subtract b. So 5 is going to be ax equal to ax plus b. Subtracting b from both sides, 5 minus b is equal to ax. And then dividing both sides of the equation by the a, 5 minus b divided by a will be equal to x. At this point right here, you could have decided to go a different way and subtract 5 from both sides, leaving us now negative ax will be equal to b minus 5. We would then divide both sides by the negative a, and that will give us x is equal to b minus 5 divided by negative a. These give us exactly the same values. So 5 minus b over a is the same as b minus 5 over negative a. If you're ever unsure, just try them with numeric values, but do have that confidence to work both ways. I would personally subtract the 5 from both sides and divide by negative a. The way I see it, a started its life off, it was multiplied by negative a, and then it had 5 added to it. So I just work back from there. Okay, let's look at another one. This one right here, 7p plus qx is equal to L over 2. So 7p plus qx is equal to L over 2. So we want to make x the subject. That means I don't want this 7p on the left-hand side. So what we're going to have is qx will be equal to L divided by 2 minus the 7p. And at this stage, we would simply divide both sides of the equation by the q. So L over 2 minus 7p divided by q. You could argue that to tidy this up, multiplying the numerator and the denominator, this fraction, by 2, we would have now L minus 14p over 2q. And that's a nicer way of writing it. Or what you could do is combine the fractions here and then simply divide out. Entirely up to you. At this stage, I'm kind of thinking that you should hopefully be fairly confident with what you're doing. Let's look at this one right here. 1 minus a squared multiplied by x is equal to b. I'm going to subtract 1 from both sides. So minus a squared x is equal to b minus 1. I'm now simply going to divide both sides of the equation by negative a squared. So that gives me b minus 1 over negative a squared. We're making x the subject. You could have added the a squared x to both sides, subtracted b, and divided by positive a squared. It's entirely up to you. I just think it's nicer to do it this way. Right, let's do this one right here. So with this one, what we've got, let's go for that one, we've got 4a minus bc squared x is equal to d cubed. I'm going to subtract the 4a from both sides. So we have negative bc squared x is equal to d cubed minus 4a. I'm simply going to divide by this quantity of negative bc squared. That's going to leave me x. If I think x is multiplied by this to give that, so this one divided by that one, for want of a better expression, will give us x. And again, you could have gone the other way by adding this to both sides, subtracting the d cubed and dividing by the positive quantity. Should we do this one? Let's go for this one right here. So here we've got y squared over z minus x multiplied by p squared is equal to q squared. Now if we just look at this, all we're trying to do is make x the subject. We've only got one x in there and it's only to the first power. It looks a mess, but it really isn't. We're just trying to isolate the terms in x. So this way I will go and make things slightly easier if you prefer. I'm going to say that y squared over z will be equal now to positive xp squared plus q squared. I've just added that to both sides. If you don't like the idea of the negatives, you can just add it to both sides. Subtracting the q squared from both sides, y squared over z minus q squared has us now equal to xp squared. The reason I've done that now is to simply have x by themselves, or x multiplied by something by themselves, and then everything on the other side that doesn't have an x in. So y squared divided by z minus q squared divided now by the p squared is going to be equal to x. Whatever you do here, don't be tempted just to say I'm going to square root each of these terms. It's not going to work like that. That would be breaking maths. So x is equal to y squared over z minus q squared all over p squared. And as stated, if you really wanted to tidy this up, we could multiply the numerator and the denominator by z. So y squared minus z q squared all over now z p squared, if you wish. That would not be expected necessarily. I just think it looks nicer like that. I suppose by the time we're 30 odd minutes into this, I'm sort of assuming a certain level of understanding from there. Right, let's see what else we've got. We'll do some different ones. Okay, with these ones, now just a range of different ones again. So we've got 3 multiplied by the quantity x minus 2 is equal to 5. Divide by 3, add 2. If we look at this one here, I'll do this one. Now there is a temptation here to expand the brackets. We don't need to. So what we've got then is the following. At this stage, we've got a multiplied by this quantity is equal to c. So x started its life off, we added b, then we multiplied all of this by a. So we're going to just divide. So that's going to be c over a. We're simply going to subtract the b from both sides. So it's c over a minus b, if you like. And that's perfectly fine. Again, if you wanted to combine the fractions, c minus ba all over a. So nice and logical, nice and straightforward. Let's start pushing things out and doing some really quite interesting stuff. Okay, let's look at this one right here. What we've got then is 2, the quantity y minus 1 plus 3 lots of the quantity y minus x is equal to 1. Okay, so I want to just make this the subject right here. So what I'm going to do is subtract this quantity from both sides. So that's going to leave me now 3 lots of y minus x will be equal to 1 minus 2 lots of y minus 1. So that's what we end up with. I now need to expand the, I now need to divide both sides by 3 on here so I can essentially expand the bracket. So if I divide both sides by 3, that's going to give me 1 minus 2 lots of y minus 1 divided by 3. I'm now at this stage going to subtract y from both sides. So we've got now negative x is equal to 1 minus 2 lots of y minus 1 divided by 3 minus the y. At this stage, I'm simply going to divide both sides of the equation by negative 1. So if I do that, I'm going to have x is going to be equal now to negative 1 lot of 1 minus 2 lots of y minus 1 over 3 minus y. That looks messy. We can of course tidy that up if we want, and we could have gone with a different route. Either way round, that is what we're going to end up with. We've got x stuck in here and it's a negative. You could have argued that you could subtract that from both sides and expand it out. It's entirely up to you. There's lots of different ways. Whichever way, this is what we're going to have, and it looks something like so. So if you wanted to tidy this up, we could just go ahead and write this as negative. Then in the numerator here, I'm going to have now 1, then I'm going to have minus 2y plus 2. So that's going to give me 3 minus 2y over 3. Then I'm going to have minus y. So I can write this as x is equal to now negative. Just combining this up, this is going to give me negative 3y. So we'll have 3 minus 5y all over 3. And of course, if we wanted, we could multiply through by the negative. It's entirely up to you. So we could write this as now x is equal to 5y minus 3 over 3. And lots of different approaches to that. Again, I'm assuming a certain level from there. I personally think that's very messy. Looking at it different ways, you might want to expand it out depending on how clean you want it to look. I'm happy with it this way, but lots of different approaches. Okay, let's go for this one right here. So what we've got then is g is equal to r squared minus the quantity b plus s multiplied by x, and we want to get x. With this one, I am going to add this quantity to both sides. So what we're going to have is the quantity b plus sx plus g is equal to r squared. So what I can do now is subtract from here the b and the g. So if I do that, what I'll have is fine. Let's go ahead and do that. We're going to have now s multiplied by x will be equal to r squared minus g minus b. And you could write that as minus the quantity g plus b, and then dividing both sides now by the s, r squared minus g minus b, all divided by s. And that would give us what we wanted. We certainly didn't have to. What I could have done is subtracted the g from, and let's just do this in a way. Let's say I subtracted, so starting here again, what we're going to do now is go ahead and we're going to have now g minus r squared is equal to negative. So let's actually do that rather than just rewriting it. G minus r squared. So I'm just writing the equation out again. G minus r squared is going to be equal to negative the quantity b plus sx. I'm going to divide both sides of this by negative 1, which is going to give me r squared minus g is equal to b plus sx. I'm then going to subtract b from both sides. So r squared minus g minus b is equal to s multiplied by x. And then divide both sides now by the s. And that will give us now this value right here. So that's what we've done that way around, and as you can see, it gives us the same value. And lots of different approaches. If you've got a different approach, feel free to use it as long as you're remaining rigorous in terms of the mathematical part. Okay, let's just do this one right here. So with this one, let's think logically what we could do. Lots of different approaches. So what we want to do is make x the subject. So if we do this, and I'll show you a few different ways on how you can do these. So what we want to make x the subject. The first thing I'm going to do is just multiply out the brackets. So what we're going to have is w minus 3w, then we're going to have plus now 3 lots of x, and that is going to be equal to y plus 1. So in this particular case, expanding the brackets this way is going to make things nice and convenient. So we have negative 2w plus 3x is equal to y plus 1. I just want x's by themselves, so I'm going to add the 2w to both sides. So 3x will be equal to y plus 1 plus the 2w, and then we're just left now to divide both sides by 3. So y plus 1 plus 2w divided by 3 will give us that. We didn't need to do that. What we could have done at this stage is subtracted w from both sides, divided by negative 3, subtracted w, and divided by -1. As you can see, lots of different approaches. I think this one's quite nice though, because we've got the w's just here. Okay, this one's going to be very messy, as we've got now this x in here, negative tx. So we want to make x the subject. So at this stage, I've got lots of different choices. What I'm going to do at this stage now, and I'll think of a couple of different ways on it. What I'm going to do is add this quantity to both sides. So what we're going to have is b is going to be equal to ra minus b, and then we're going to have plus a multiplied by r minus tx. I'm going to now subtract ra from both sides, add b. So we're going to get now 2b minus ra will be equal to a multiplied now by r minus tx. I'm now going to divide both sides by the a, so 2b minus ra divided by a will be equal to r minus tx. I'm going to subtract the r from both sides, so 2b minus ra over a minus r is going to be equal to negative tx. I'm then going to divide both sides of this equation by negative t. So 2b minus ra over a minus r, all divided by negative t, is equal to x. We can tidy this up and do lots with it, multiplying the numerator and the denominator by the a and doing a bit of factoring, but that is never going to be very pretty. An alternative here would have been to just expand the brackets. So b minus ar, then we're going to have plus atx is equal to ra minus b. So all I've done this time is expanded the brackets. Minus ar, we got two negatives, which will give us atx. So at this stage, what I could have had is now atx on the left-hand side. I'm going to subtract b and add ar. So if I do that, I'm going to have now subtracting the b, I'm going to have negative 2b. And then if we just consider what I'm going to have at this stage right here, if I look at this, negative ar and ra and ar are the same things. So I'm going to have 2ra and then I'm going to have negative 2b. I'm going to divide both sides now by the at, and this is going to give me x is equal to 2ra minus 2b over a multiplied by t. And again, you could argue that you're going to factor that the numerator. So you could write this as x is equal to 2, the quantity, ra minus b divided by a multiplied by t. So if you wanted to take some values, let's say that a was equal to 1, b was equal to 2, and t was equal to 3. If you substitute them into this one and this one, you will have exactly the same numeric value. I think this one looks a lot tidier, but again, we're just now working backwards. We're trying to work out how we're going to get x out of here. Okay, let's move on and look at some more. What else have we got? Okay, so these ones right here, let's see on here. We'll do this one. We got 2s minus ex over 3 is equal to s, and we want to make now the subject, right, let's write this 2e minus x, and then we're going to have this divided by 3, and that is going to be equal to s. What I'm going to do with this one is make this slightly more interesting, and instead now of making x the subject, I'm going to make s the subject. So at the moment you might say, well, s is the subject, but it's expressed in terms now of s and e and x. So I'm going to make s the subject, and when you see this in a question, you'll just see s given, so that's what we're going to do. So what we're going to have then is 2s minus ex is going to be equal to 3s by multiplying both sides by 3. So at this stage, all I'm going to do is subtract 2s from both sides, so negative ex will be equal to 1s, and we've made s the subject. If I wanted to make x the subject, well, x is stuck in the numerator. We've got two lots of s minus ex over 3 is equal to s. So I'm going to multiply both sides of the equation by 3. So we're going to have now 2s minus ex is equal now to 3 lots of s. This is a problem with my 5s and s's, they look a little similar. What we're now going to do at this stage is subtract the 2s from both sides. So we've got to negative ex is equal to s, and we're going to divide both sides now by negative e. So we get s over negative e, which of course you could write as x is equal to negative s over e. And that gives us what we wanted. So with that one, we looked at that, and we can see from here that we could simply divide both sides by the negative e to get s. So we could have rearranged it from that point, but I think that's interesting nonetheless. Okay, let's look at this one right here. So with this one, in fact, I'm going to be a bit cheeky with this one. I think we're going to push things on a little. So by this stage, 3/4 now in, I'm kind of assuming a decent level of knowledge, because I'm going to start taking a few, not risks, but a few liberties with this. So what we're going to do then with this one, 2p plus 1 over a plus sx, and then I'm going to subtract 1 from both sides. Okay, so what at this stage I'm going to do is divide both sides of the equation by the r minus 1 and multiply both sides of the equation by a plus sx. So if I do that, if I multiply this side by a plus sx, that will now essentially cancel. And if I divide, that's going to give me r minus 1. On this side, the r minus 1s will cancel, and that will give me a plus sx. So essentially all I've done is just rearrange them. If you wanted a different way of looking at that now, if we think that 4 over x is equal to 2, what we could say from this now is that 4 over 2 is equal to x. And the reason being, if you multiply it by x, we've got 4 is equal to 2x. And then you divide down by the 2, 4 divided by 2 is equal to x. So all I'm doing is simply taking 2 steps here and just rewriting this. Instead of having the hassle of messing about, I'm simply going to go ahead and make that alteration from here. Okay, so at this stage, I'm going to write that this is going to be 2p plus 1 divided by r minus 1 minus a is equal to s multiplied by x. I just want x, so I'm going to divide both sides of the equation by the s. So r minus 1 minus a all divided by s. It's not just one part, it's all divided by s, and that is going to be equal to x. If you wanted to tidy this up, you could multiply the numerator and the denominator by r minus 1, 2p plus 1 minus a multiplied by r minus 1 all over s multiplied by the r minus 1, and that would give us now x. And again, you could look at just tidying that up. But again, if you've got to that stage, that's pretty good going. Okay, so if we look at doing this one exactly the same, we've got now, so a over now b minus cx minus a is equal to d. So this time what we've got in here now is the x is in the denominator. So I need to get to that, so I'm going to add the a to both sides. So what we're going to have is a over b minus cx is equal to a plus d or d plus a. Swapping these over, we can now say that a over a plus d will be equal to b minus cx. Subtracting now, so a over a plus d, subtracting b from both sides is equal to negative cx. Dividing both sides of the equation now, so a over a plus d minus the b divided by negative c, so divided by negative c is going to give us x. And as stated, you could go ahead and tidy that up if you wanted to. I personally, well, you could do, depends what, if they ask you to put it in a certain form, you could go ahead and do that. Okay, let's try this one to finish with. So let's go for this one right here. So what we've got here is the following. We've got d plus 2 multiplied by the quantity x plus d is equal to 1. So d over d plus 2 lots of x plus d is equal to 1. I'm just going to swap those over. So I'm going to write that d over 1 will be equal now to d plus 2 lots of x plus d. So I'm just simply now multiplying that, because remember, this is one lot of this quantity. So what we now have is d is equal to d, and then we're going to have on here d plus 2 lots of x plus the d. Subtracting d from both sides of the equation, that is going to leave us 0 is equal to 2 lots of x plus d. I'm going to divide both sides of the equation by 2. So 0 divided by 2 gives us 0. That gives us x plus d. And then subtracting d from both sides, x is equal to negative d. So all of that now just goes and gives us that x is going to be equal to negative d. Now if you think about that, if x is equal to negative d, what we have here is d over d plus 2 lots of negative d plus d, and that should be equal to 1. Well, this right here is going to give us 0. D over d, of course, is going to give us 1. So nice little one to work with on there, and again lots of different approaches. Right, let's see what else we've got. See if we've got any others. See if we've got some changed over. We'll look. If not, we'll do a few more of these. There should be some more somewhere. Okay, let's have a look at these ones right now. So this time we've got a whole range of different things. Okay, let's just have a look at this one. We'll go for this one. So what we've got now is x in one of the brackets and x in the other bracket. We need to expand these to make x the subject. So expanding them, the first one I'm going to have 3ax minus 3b plus 2bx plus 2c is equal to 1. At this stage, I'm going to collect everything on the left-hand side with an x in. So that's that one and that one. So what I'm going to have is 3ax plus 2bx will be equal to 1. I'm then going to add 3b to both sides and subtract 2c. So what I've done here is taken these ones that don't have an x in, and we've put them on the right-hand side, and then on the left we have terms in x. Factoring the x out, x is common to both. That leaves me 3a plus 2b, and that will be equal to 1 plus 3b minus 2c. So x is going to be equal to 1 plus 3b minus 2c over the quantity 3a plus 2b, and that is what we're going to end up with. So that's quite a nice one when we're looking now at factoring. Okay, let's look at this one right here. So again, we've got ax, so we've got an x in the numerator, and we've got an x over the other side of the equation. So let's go ahead and do that one. What I'm going to do here is multiply both sides of the equation by c. So to clear the fraction, I'll just write it out from the start. Ax plus b divided by c is going to be equal to s multiplied by x plus h. I need to get the x's on one side. That means I need to clear this fraction. So ax plus b will be equal to c multiplied by sx plus h. I need at this stage to expand the bracket. I want to get the x's over here. So ax plus b will be equal to csx plus ch. At this stage, I can subtract the csx from both sides and subtract the b. So on the left-hand side, I'm going to have ax plus csx plus the b, and I'll do it step by step, is equal to ch. So subtracting b from both sides, ax plus csx is equal to ch minus b. I can factor now the left-hand side, taking x out. A plus cs is equal now to ch minus b. Dividing both sides of the content by the content of a bracket, ch minus b divided by a plus cs gives me x. So quite a nice little example there. Okay, let's have a look at some others. Right, this one right here, let's do this one right here. C over x plus d over x is equal to e. I'll do this one just here. What we have here is a common denominator. So if I had, let's say, 1/5 plus 3/5, I could just add them together to get 4/5. So what I can do is just add these. So c plus d over x is equal to e. We can use the trick again. C plus d divided by e is going to be equal to x. So that is going to be nice and straightforward. So really quite nice. All we've done is we've got the common denominator and we've gone from there. Okay, let's now look at this one right here. This looks to be a complete mess as we've got x and x now in the numerators of two fractions with different denominators which are algebraic, so they're not numeric. Okay, this requires a certain level of understanding. What I'm going to do is get a common denominator. The common denominator is the product of A and E. So if I have that, and if you've watched the video on algebraic fractions, this will make sense. I'm now going to multiply all of this equation by E to get the common denominator, and that will be 2E, and then we're going to have 1 minus bx. Then if I consider now I need to multiply this side by the A, we're going to have 3A, and we're going to have cx plus d, and that is going to be equal to f. I'm going to multiply both sides of the equation by now A multiplied by E. So what we're going to have is 2E will have 1 minus B multiplied by x plus 3 lots of A multiplied by cx plus d is going to be equal to A multiplied by E multiplied by f. I'm now going to expand the brackets. 2E minus 2BEx plus 3ACx plus 3AD is equal to AEF. Collecting now the terms in x, I'm going to have now 3ACx minus 2BEx, and I'm going to subtract from the other side anything that doesn't have an x. So we're going to have AEF minus the 2e minus 3ad. Factoring now the x out from here, x is common, that's going to leave me 3ac minus 2be, and that will be equal to aef minus 2e minus 3ad. Dividing by the content of a bracket, we have aef minus 2e minus 3ad, all divided by the quantity 3ac minus 2be. So with that one, really quite a decent sort of level of understanding required for that, as we're looking at making something quite tricky the subject of the equation. I think looking at them, that seems about the hardest one there would be on that. Now we'll look at this one. Let's look at this one right here. So this one right here, let's do this one. We've got y is equal to x plus ax over b, and we need to make x the subject. What I'm going to do is combine the fraction here. So I'm going to get a common denominator. The common denominator is going to be b. Okay, so this is one way that I could do it. It's certainly not the only way, but it's one way. So what I'm going to do is have xb plus ax. So all I've done is combine those. Multiplying both sides by b, so we'll have b multiplied by y, or yb. That's going to be equal to x multiplied by b plus ax. X is now common on the right hand side, so we've got by is equal to now x, and I'm going to write b plus a, or I could write a plus b. Dividing both sides by the content of a bracket, y multiplied by b, or b multiplied by y, divided by a plus b is equal to x. That is one way that you could do it. I think that's the nicest way looking at it. Okay, let's see if we can do a couple more. Let's do this one. This one is going to be a case of numeric, so this one shouldn't be too hard. So common denominator is going to be 12. So using my common denominator, 12, I need to multiply this side by the 4. So we're going to have 4, then we're going to have x plus a. Then we're going to need to multiply this one by 3. That's going to be 3 lots of x plus b, and that will be equal to 1. So at this stage, multiplying both sides by 12, we got 4 lots of x plus a, plus now 3 lots of x plus b is going to be equal to 12. Expanding the brackets, 4x plus 4a plus 3x plus 3b is going to be equal to 12. I can see I've got 4x and 3x, which gives me 7x. And then I'm simply going to subtract the 3b and 4a from both sides. So 12 minus the 3b minus the 4a, and we're now going to simply divide by 7. So 12 minus 3b minus 4a, all divided by 7 gives us x. So that's quite a nice one as well. So we're just looking at going ahead and doing them. This one right here, let's do that one. So common denominator is AB, it's the product of the two. So we have AB, multiplying this one by the b, we would have 2bx. Multiplying this one by the a, we would have 3ax, so 3ax, and that would be equal to c. I'm going to multiply both sides by ab, so we have 2bx plus 3ax is equal to abc. Easy as ABC I really want to say at this stage, but quite clearly not. X is common to both of these. X, 2b plus 3a is equal to abc. Dividing both sides by the content of a bracket, abc divided by 2b plus 3a will give us the answer. So that's quite a nice one as well. Okay, let's move on. We've done an hour. We'll see if we can find any more to work on that look a bit nasty. In fact, let's just look at one. Let's go for 1 over p plus 1 over q is equal to 1 over r. What we're going to do is, and this is quite a nice one, let's go ahead and make q the subject of this equation. So if I just put we're making q, so what I'm going to do is subtract 1 over p from both sides. So what we're going to have is 1 over r minus 1 over p. At this stage, there is a temptation to simply invert this. We can't do that. What I am going to do is combine these fractions right here. So what I'm going to do is now write with the common denominator of rp or pr, we're going to have now p, so 1 multiplied by p, and I'll write it out, 1 multiplied by p minus 1 multiplied by r. So we have now that q is equal now to p minus, 1 over q I should say, 1 over q is equal to p minus r over pr. Now we can invert this. So turning this upside down, we've got q over 1 will be equal to p r over p minus r. So q is equal to pr over p minus r, and that gives us what we want. So that's one way of doing those particular ones. Again, if you wanted to make p the subject, you would do exactly the same, but obviously with the slight alteration. Let's see if we've got any more to finish off with. Okay, so let's, some of these look fairly straightforward. This one, divide by 2 and take the square root of both sides. This one, now with this one, let's just look at this one. 3x squared over 5 is equal to d. Now you might say to yourself, I'm going to now multiply both sides by 5 and divide both sides by 3. That is the same as saying I'm going to divide both sides by 3/5. Remember, this is just 3/5 multiplied by x squared. So if you divide both sides by 3/5, then x squared is going to give us now 5d over 3. So often students say multiply by 5, divide by 3, perfectly fine, but it's the same as dividing by 3/5. So we need the square root, and this is going to give us now x is going to be equal to plus or minus the square root of 5d divided by 3. If you're doing surds, you might be asked to write that with a rational denominator, but again, that's not really part of what we're doing here. Okay, let's look at some more challenging ones. Let's look at this one right here. So we've got x plus 2, so x over 2 plus a, all squared is equal to b. So what we want to do is now go ahead and essentially make x a subject. So what we've got, x was divided by 2, it had a added to it and it was squared, that gave b. So I'm now going to go the opposite way. So I'm going to take the square root of both sides. That is going to give me plus or minus the square root of b. I'm now going to subtract the a from both sides. So we'll have x over 2 is equal to plus or minus the square root of b minus a. And don't get confused, don't put it under the root here. And then all we're going to do is x is going to be equal now to 2, we're multiplying both sides by 2, plus or minus the square root of b minus a. So that will now make it the subject. X is the subject. Okay, let's look at this one right here. So this one here is going to be r squared is equal to 2 lots of p plus ax over t all squared. Dividing both sides of the equation by 2, r squared divided by 2 will be equal to the quantity p plus ax over t all squared. I'm going to take the square root of both sides. So if I do that, I'm going to have plus or minus the square root of r squared. And I'll do this, in fact, I'll write it like so. I'll do it a couple of different ways. And that is going to be equal to p plus ax over t. At this stage, I'm now going to subtract p from both sides, but I'm going to write this differently. If I write this as the square root of r squared over the square root of 2 minus p, on the next phase, I can just go ahead and rewrite this. What I'm going to say now is that I'm going to divide both sides of the equation by at. But if I just write this first, what we're going to have is plus or minus now r over root 2 minus p divided now by a over t. You could have said now at this stage that what you're going to do is multiply both sides by t and divide by a. What this is going to give us now is t, so we'll have t multiplied by plus or minus r over root 2 minus p all over a, and that will give us x. Again, you could argue that you don't want the irrational number in the denominator, and you could multiply through or just rationalise the denominator. So plus or minus r root 2 over 2 from there. So that's another way that you could do it, and we may as well do that, because I think if we're at this stage, plus or minus, and then we're going to have r root 2 over 2 minus p all over a, which we could write even further if we wanted now, is t. And we could write this even as t over 2a, and then we would have plus or minus r root 2 minus now the, what we can have, minus 2p, and that will give us the value of x. So this is just looking at alternative ways. If you're at this stage, I'm kind of taking liberties to sort of think, well, you might know that. If not, perfectly fine if you don't. Okay, let's go ahead and do this one. So this one here, we've got two lots of x minus a to the 4th divided by y. Well, if we do this one first, let's just do this one first. So we've got 2, and then we've got x minus a all squared is equal to y. Dividing both sides by the 2, x minus a all squared is equal to y over 2. Taking the square root, x minus a will be equal to plus or minus the square root of y over 2. Adding a to both sides, a plus or minus the square root of y divided by 2. If we have an even power, we're going to have a plus or minus answer when we take the root. So if we look at this one right here, what we're going to have then is 2 x minus a to the power of 4 is equal to y. Dividing both sides by the 2, x minus a to the power of 4 is equal to y divided by 2. I'm going to raise both sides of this equation now to the power of 1/4, or if you like, I'm going to take the 4th root of both sides. So we're going to have x minus a is equal to plus or minus, and I'm going to write this now as y over 2 to the power of 1/4. You can, of course, write this as the 4th root, like so. It's entirely up to you. Like, even notation is fine. So what we're going to have, add in the a to both sides, a plus or minus now y over 2 to now the power of 1/4. If that had been the 3rd or the 5th or the 7th, we only have now one answer. We don't have a plus or minus. So if we look at this one, I'm going to go ahead and take the cube root of both sides. So we have ax cubed plus 1 is going to be equal to the cube root of y, or y to the 1/3 power. Then we're going to have a multiplied by x cubed is going to be equal to, and I'll write it to like so, y to the 1/3. You can, these things are identical, minus the 1. I'm then going to divide both sides by the a. X cubed is equal to y to the 1/3, so y to the 1/3 power minus 1 divided by a. I'm now going to take the cube root of both sides. I'll only have now 1. It's not going to be a plus or minus, and we'll have y to the power of 1/3, which I could write like that, minus 1 over a, all to the power of 1/3. Or you could use this notation again. I'm switching up. I will let you decide. Okay, let's look at, we'll finish with these two. Now these are very, very cheeky and quite nasty because we have quadratic expressions here and we want to make the x a subject right here. Now if I look at this, I've got two choices. If I can factor it, I'm going to factor it as now a perfect square. This will factor as a perfect square. So on the left hand side, if we have factor back, that's x plus 1 multiplied by x plus 1, which is going to be equal to t. We can write this now as x plus 1 all squared is equal to t. So with this one, you think, oh, I've got an x in it, because if you start messing about with it, the x's are gonna, we're essentially looking to get x rather than x squared, and I'll let you play around with it. So now we can say that x plus 1 is equal to, taking the square root of both sides, plus or minus now root t. So x is going to be equal to negative 1, subtracting 1 from both sides, plus or minus root t. So that's what we get. Alternatively, if this didn't factor, we could have completed the square. So if we think about this, completing the square. So let's say I had now x squared, and we'll go for minus 4x, and then we have, let's say, plus 1 is equal to y. Now let's say we were asked to make x the subject of this equation. We can't factor this. So completing the square, x minus 2 all squared minus 4 plus the 1 is equal to y. So x minus 2 all squared minus 3 is equal to y. So we could say y plus 3. Taking the square root of both sides, x minus 2 is going to be equal to plus or minus the square root of y plus 3. Adding 2 to both sides, x is equal to 2, plus or minus the square root of y plus 3. And we'd have to say that y is going to be at least negative 3 here to give us some real solutions, as we can't take root of a negative number to give a real value. So this one, we'll finish off with this one. That now will factor as a perfect square. So x plus 3 multiplied by x plus 3 is going to be equal to t. So we could say that x plus 3 all squared is equal to t. Taking the square root, x plus 3 is equal to plus or minus the square root of t. So x is going to be equal to negative 3 plus or minus root t. And that works nicely. Again, if you wanted to complete the square, then you'd have x plus half the coefficient, which is going to be 3, all squared minus 9 plus 9 is equal to t. So you can see from there, they will cancel and we're left with what we had. So really quite, at this stage, we're looking at some really quite tricky kind of things and messing about. But hopefully that gives you some idea on how to do these. It's just a case of using the order of operations, or if you like, the inverse functions, playing by the rules now of inverse functions and thinking logically. How can I get x on one side, or whatever the variable you're trying to make the subject, and go from there.